So we looked at permutations, we looked at combinations. Now, when we're doing an exercise on permutations, we know it's a permutation. When we're doing an exercise on combinations, we know it's a combination. But of course, when it comes to assessments, it's not like they start the question and go, by the way, this is a permutation. Alright? So the next exercise we're going to look at is, we've got to work it out. Is it going to be a permutation? Is it going to be a combination? So I'm just going to look at a couple of HSC questions via example. So 2007 one, Mr. and Mrs. it says, Mr. and Mrs. Roberts and their 4 children, you'll note this time spelt correctly, go to the theatre. They're randomly allocated 6 adjacent seats in a single row. What's the probability that the 4 children are allocated seats next to each other? Okay. Well, it's a probability question, so the bottom of the fraction, total way of arranging the 6 people, so I'm just using the basic counting idea for that one. Use them all, 6 factorial. On the top of the fraction, well, the 4 children need to be in a group of their own, so that's the 4 factorial. But then it becomes like arranging 3 objects, the 2 parents and the 1 group of children. And so we get 3 factorial, 4 factorial on the top, giving us our final answer of a 1 in 5 chance. There's a 1 in 5 chance. Now let's look at extension 2 from that year. I think I was even mentioning this, was it yesterday or the day before? When it comes to these perms and comms questions, the 3-unit ones, or extension 1, so that was an extension 1 question, they tend to be reasonably straightforward. Extension 2 is a lot more fun. Sometimes I have to do a bit of thinking here. So a bag contains 12 red marbles, 12 yellow marbles, and 6 marbles are going to be selected without replacement. We want to know the probability that exactly 3 of the selected marbles are red. So we want 3 to be red. So probability 3 to be red. In this case it's a combination, because we don't care the order we pull the marbles out, we're just grabbing the marbles. So bottom of the fraction, there's 24 marbles all up. I'm going to select 6 of them, so 24C6. On the top, I want to select, what was it? Exactly 3 red, which therefore means we're also going to get exactly 3 yellow. So 12C3 times 12C3, and they've said to do it as a decimal, so 0.36 to 2 decimal places. Hence or otherwise, calculate the probability that more than 3 of the selected marbles are red. Again, giving your answer correct to 2 decimal places. Hence or otherwise. Probability of greater than 3 red. Well, that would be 4 red, 5 red, and 6 red. So I could just do it that. So this, I guess, would be the or otherwise. I haven't used my answer, you'll notice, to part I. But they've given me that option. So I could work out 4 red, so 12C4 times 12C2, 5 red, 12C5 times 12C1, and all red, 12C6 times 12C0, which of course is just 1. And we get our answer, 0.32. But I wasn't happy with that because they said hence. So there must be an interesting way of doing it using part I. Here's the interesting way. Probability of greater than 3 red using the complementary idea would be 1 minus the probability of 3 red, but also minus the ones where there's less than 3 red. Well, the probability of less than 3 red would be the same as greater than 3 yellow. But the probability of greater than 3 yellow would be exactly the same as the probability of greater than 3 red. And now I could think of this as not lines of working out, but I could think of it like an equation. And I can move the probability of greater than 3 red to the left-hand side, and I now know twice the probability of greater than 3 red will simply be 1 minus the probability of 3 red, which is what we worked out in part I. So dividing by 2, 1 minus probability of 3 red, and sure enough we end up with a 0.32. So that would be the hence way of doing it. 2006. Oh yes, this was good. Sometimes you've got to read the instructions real carefully. we've got a chess match between the very cleverly named home team and away team. So a game's going to be played on 4 boards. So board 1, board 2, board 3 and board 4. So on each board, the probability that the home team wins is 0.2, probability of a draw is 0.6, and the probability the home team loses is also 0.2. In other words, the home team and the away team equally likely of winning and losing there. The results are recorded by listing the outcomes of the games for the home team in board order. So to make that clear, they've said, as an example, if the home team wins on board, that should be board 1, shouldn't it? Home team wins on board 1, draws on board 2, loses on board 3, draws on board 4, then we'd write the result down as WDLD. So win, draw, loss, draw. Okay. How many different recordings are possible? Well, again, this one's just a basic counting idea, because on each board there's 3 possibilities, a win, draw or a loss. So it'll be 3 times 3 times 3 times 3, so there's 81 different possible recordings. Of course, they're not all equally likely, because the draw, you'll notice, has more chance of happening than the win or the loss. So calculate the probability of win, draw, loss, draw. Okay, well, win, draw, loss, draw. Win was 0.2, draw was 0.6, loss was 0.2, draw was 0.6. Multiply them all together, and we have a probability of 0.144. Now's a good time to point out that just because it's extension 2 doesn't mean there's not easy marks to be had. And if you think about it, those first 2, okay, they're pretty straightforward. Now, teams score 1 point for each game won, half a point for the game if the game's drawn, and 0 if you lose the game. What's the probability that the home team scores more points than the away team? Now, you'd love to say, it's got to be 50-50 surely, but remember there's also a chance they might have the same number of points. Okay. The way I approached is I said, well, first of all, I'm going to work out the probability of them actually getting the same number of points. Okay. So same number of points, how could they do it? Well, if we draw on all 4 boards, that would give them the same number of points. 2 wins, 2 losses. That would give us the same number. But you'll notice in my 2 wins, 2 losses, sure, that's 0.2 squared times 0.2 squared, but then there's the number of ways I could arrange WWDD. Because it might be win on the first, draw on the second, win on the third, draw on the fourth, or it might be win on the first, win on the second, draw on the first, draw on the second. So it's like really saying how many words can you form out of 2 W's and 2 D's. And each one of those would have a probability of 0.2 squared times 0.2 squared. How else could we get equal points? We've got 4 draws, 2 wins, 2 losses. I know. Yes, 1 win, 1 loss, 2 draws would be a possibility as well. 0.2 times 0.2 times 0.6 squared, but now times the number of ways we could arrange WLDD. So that's times the 4 factorial, 2 factorial, and we get 0.1728. I think that's it. There's no other way we could get equal points, is there? I think that's it. So total them up, we've got 0.312. So I now know the probability that they get equal points. Therefore, the probability that they get unequal points is 0.688, and that is going to have a 50-50 chance. Because win-loss, remember, was equally likely. So the probability we're looking for would be half of that. And so half of the unequal gives us 0.344. So a little bit more thought than just your standard perms and coms question. Let's try this one. We've got 9 cards conveniently numbered, 1, 2, 3, up to 9. 3 cards drawn at random, and then we place them on the table from left to right. What's the probability that the number that it creates exceeds 400? Okay. Well, it's simply going to be 6 in 9. because I don't have to worry about the second two digits if you think about it. For it to be greater than 400, really we're saying, what's the probability that the first number is bigger than 4? Oh, actually, no, bigger than or equal to 4, isn't it? Because it'd be 400 and something. And so that gives us our 6 out of 9, 2 out of 3. Okay. What's the probability that the digits are drawn in descending order? Now that doesn't necessarily mean consecutive, it just means in descending order. So I might go 9, 2, 1, 8, 3, 1, descending order, whatever the digits are. Well, whatever the 3 digits that I pull out, I know there's going to be 3 factorial ways of arranging those 3 digits. How many of those arrangements will they be in descending order? So there's your probability. So the probability is 1 in 6. It doesn't matter which 3 digits I pull out. Whatever the 3 digits are, there's always going to be 3 factorial ways of arranging those, and only one of them will be descending order. Had you bothered to work out every possible one and then worked out how many of those would be descending, yes, you'll get a different fraction, but guess what? It would simplify down to be 1 in 6. Alright. So anyway, there's a couple of the extension ones. 10H has now got a mixture of perms and combs. You need to work out, okay, is this going to be a permutation? Is this going to be a... In other words, is order important?